Alright guys, so we are now on number 10. Alright, so number 10 reads, Harvey and Emily are hosting a breakfast for their teachers. If Harvey bought 6.5 liters of orange juice and Emily bought 163 milliliters of orange juice, how much orange juice in liters did they have in total? Okay, so we got a couple conversions. Notice how it says 1 liter is equal to 1,000 milliliters. We're going to take that and we're going to go ahead and set it up for Harvey and Emily. Okay, so Harvey gets his own little section and Emily. Now I told you that whenever they give you some sort of conversion or comparison with the equal sign in parentheses, we're going to use that as a fraction. So I'm going to set that up. 1 liter per 1,000 milliliters. Okay, same thing for Emily. 1 liter for 1,000 milliliters. Okay, so the same thing, I'm going to say liters per milliliters has to be the same for my given ratio, liters per milliliters. So it says Harvey bought 6.5 liters. If it says 6.5 liters, that means I'm going to probably make that my numerator, okay? I'm trying to solve for milliliters because that's what it asks. All right? In Emily's case, it says that she bought 163 milliliters. Ooh, so she doesn't bring liters, she brings milliliters. So that's 163. So we solve for liters for her. And then we need to make sure that our total, because it says how much orange juice in liters did they have in total. So then we're going to look at these 2 liters and then we're going to total it. Okay, so let's start with Harvey. It says from 1 to 6.5, okay? 6.5. Remember I told you bigger number divided by the little number. In this case, it's 6.5. So my scaling factor is 6.5. Again, we want to look at where our arrows go. And we always go toward the x. And I'm going to do that for my numerator as well. So that means if I look from 1 to 6.5, I'm going to a bigger number. It means I multiply. So 1,000 milliliters times 6.5 gives me 6,500 milliliters for Harvey. Okay, let's figure out Emily. Emily, we're going to do the milliliters. So we need to find the scaling factor. So my 2 given numbers is 1,000 and 163. I'm going to take 1,000 divided by 163. I get a decimal, 6.13, and I'm going to round 5. Okay, oh, it's getting a little tight, 6.135. Okay, so now we got to figure out, we're going to go toward the x, right? 1 to x. We want to figure out, that's why we put the arrow toward the x. We want to figure that one out. So do the same thing for your denominator. So if we look from 1,000 to 163, we're going down in numbers, so we divide. That's how we figure out what we do for our numerator. So 1 liter divided by 6.135 gives me about 0.163 liters. Okay. So I told you that the question is now saying, how many liters do they have in total? I can't add milliliters with that liters. So I'm going to look for Emily. She brought that much. Okay, I'm going to put a star. This is the amount of liters she brought. Harvey, it told us he brought 6.5 liters. So if I add 6.5 liters and 0.163 liters, I get total of 6.663 liters. Okay, so they brought a total of that many liters. Okay, so let's move on to number 11. Number 11 says, Maya can run 8 miles in 72 minutes. At this rate, how long will it take her to run 10 miles? Again, guys, this sounds like some sort of comparison to me. So I'm going to use the strategy that I know by setting up a proportion, okay? And I love proportions because they're like puzzles, all right? So the puzzle piece that they give you is that Maya can run 8 miles in 72 minutes. I'm going to go ahead and set that up as a fraction. 8 miles in 72 minutes. That means my proportion or my ratio on the right should also be miles per minute. Get in the habit of labeling. That's not Miss Stilinski just doing that for fun, okay? It's going to help you be successful. So the question says, Maya can run 8 miles in 72 minutes. At this rate, how long will it take her to run 10 miles? Now it gives me 10 miles, so I'm going to go ahead and put the 10 here. And that makes sense because it says how long. If I'm solving for how long, I'm solving for some sort of time. And that makes sense since we're looking for minutes. Okay? So let's look for our scaling factor. I told you big number divided by my little number. 10 divided by 8 gives me 1.25. That's my scaling factor for my numerator and my denominator in order to make that an equivalent fraction. Okay? So I want to go toward the x always because I want to solve. So that means I'm going to go toward the 10 on my numerator. Okay, so going from 8 to 10, it's a bigger number, so I need to multiply. That means I multiply on the bottom as well to find x. Okay, so 72 times 1.25, that gives me x is equal to 90 minutes to run 10 miles, which is not realistic at all. That is super fast, unless you're an ultra runner. Okay? So again, how did I tell you you can check these? You can do 8 divided by 72 because a fraction is a decimal. You get 0.111111 repeating. Then you can also do 10 divided by 90. You get the same thing, 0.111111 repeating. Okay? So we were correct. So let's move on to number 12. Number 12 says, there are 20 boys and 15 girls in Miss Stilinski's class. If 4 boys are added to the class, how many girls must be added for the ratio to stay the same? This is kind of tough. Okay, so let's not even pay attention to the other information. Let's look at our given ratio. Our given ratio. So number 12 says, there are 20 boys and 15 girls. Okay, 20 boys, 15 girls. Okay, we want to see if 4 more boys are added to the class, how many girls must be added for the ratio to stay the same? This is a problem. If I set it up as boys to girls, I don't have any comparison to the total. So this is actually not a good proportion. So the way you set that up is not as boys over girls. Okay, so those are 2 pieces of information that's important. Okay, so we want to know some sort of total. Okay, so let's look. If I know I've got 20 boys, how many total students do I have total? I'm just focusing on the boys right now. If I add 15 to 20, I get 35 students. Okay, I hope I didn't throw you guys off because right now I'm just trying to find a total. So this is boys, remember? We're just focusing on the boys. We can also do a ratio for the girls. Okay? If I know that our 15 girls, the total of the amount of students doesn't change. It's still 35. Alright? So 35 total students. So the key was how I got 35. So hopefully you guys understood that. Now it says if 4 more boys are added to the class, how many girls must be added for the ratio to stay the same? I'm going to find girls and boys, okay? So if I add 4 to the total, that means 35 plus 4 for boys and girls. Because now there's a total of 39 students. 39 students. Now there are 39 students total in my class, okay? So if I move, I want to figure out how many boys there are and how many girls there are as well in that new total. Alright, so I'm going to go ahead and divide 39 by the smaller number, which is 35, to get my scaling factor of 1.114. Same thing for the girls. Excuse me. Alright, So I know that's my scaling factor. So we got to figure out, we're always going toward x, okay? Same thing for 15 girls to x amount of girls toward x, okay? So if I'm going from 35 to 39, that means I multiply by that scaling factor. So I multiply the top as well. So 20 times that scaling factor of 1.114 gives you about, which I know this is not realistic, 22.28 boys. All right? And if I do the same thing for the girls to figure out how many girls there will be, so this is 22.28 boys in a class 39. Let's figure out girls. So girls would be 35 or 15 times 1.114 gives me about 16.71 girls in that new class of 39. Okay, so let's figure this out. We're going to cross multiply and divide by the unused number to see if we were right. So if I look at my cross multiplication, let me use a different color. The only two numbers I can cross multiply for the boys is 20 and 39. 20 times 39 gives me 780. So I divide by the unused number. I haven't used 35 yet, so divide that by 35. I get 22.28. So we were right, okay? Let's check the same for the girls, okay? Cross multiply the only two numbers that are present that you can multiply, because I can't multiply x and 35. I don't know what x is. So 15 times 39 gives you 585. Divide by the unused number. We get 16.71. So let's double check. So I know that's really weird because you can't have a decimal of a person. But let's check because this is hypothetical. 22.28 plus 16.71. Let's see if this gives us 39 people total. It gives us 38.99. So it's just about, all right? So one of these you can round. You could say 17 girls since this would round up, okay? So this would actually give me 17 girls since the question asks how many girls there would be in that new class total, okay? Awesome, so that's how the ratio would stay the same. This was a little tough, but you can try another problem like this. I have them on the Percent Nearpod from about a week and a half ago or a week ago. This is how you would find it. If you can find that total right here and that new total, you guys will be fine. Okay, so let's move on to number 13. Number 13 says Robbie ran 150 meters in 15 seconds. Okay, Haley ran 132 meters in 12 seconds. Who ran faster and what is the difference in speed? So I'm going to set up a proportion for both Robbie and Haley. So Robbie and Haley. And it gives me a comparison for Robbie and Haley. So Robbie, it says he ran 150 meters in 15 seconds. Okay. For Haley, it says she ran 132 meters in 12 seconds. So I want to figure out who ran faster by finding the unit rate. Okay, same thing as better buy. I'm going to compare. But instead of finding the cheapest one, the better buy, I want to see who's faster. So I want to look for the bigger number. And I want to compare it to 1 second. 1 second. So how many meters can they run in 1 second? All right? So 15 to 1 and 12 to 1. So 15 divided by 1 gives you 15. So that's my scaling factor. And I always want to go toward x. So 15 to 1 means you divide. So that's what I will be doing. Okay, so 150 divided by 15 gives you x is equal to 10 meters in 1 second. Okay, so I hope you guys can see that. And if I do the same thing for Haley, if I go to 12 to 1, that means I have 12, right? So I'm going toward x, toward 1, I divide by 12, I divide by 12 on the top as well. So 132 divided by 12 gives you x is equal to 11 meters in 1 second. Again, this is not a better buy. This is who runs faster. That is Haley, and she can run faster by 1 more meter than Robbie.